moving on. So inside our foldable, we have some examples that we're going to run through here. So as we go through these, remember we always start with the y-intercept and then we finish with the slope. So we'll do the first line in red. So my y-intercept here, which is b, is going to be -5, and my slope is, in this case, 4. So I'm going to start at -5, 1, 2, 3, 4, 5. So I start here, and I have a slope of 4. That's 4 over 1. So rise over run, I'm running 1 and rising 4. And I want to put at least, when I'm doing these by hand, I want to put at least 3 points down on the line. Remember, you can always reverse both directions as well. Okay, so we've got a point there, there, and there. All right. My second equation, my y-intercept is +1, and my slope is -2. So I'm going to start at +1, and I'm dropping 2 and running to the right 1. And in this case, I already see where that intersection is going to be, but I can go ahead and reverse both directions as well and go up and to the left. I could even put another point there and there. Okay, so we can make it, the more points you put, the more accurate your lines are going to be. So our point of intersection, or our solution, okay, is right there. This is a one solution system. And so that point is at 1, -1. So we put, for our solution, we put 1, -1, and we draw a box around it just to make it nice and neat. That's the solution to the system. And what this solution means is that an x value of 1 and a y value of -1 will be true for both equations. So if we plugged 1 in for x into both equations, we would get -1 for y in both equations. And that's the only point where that's true. It is the only point that falls on both lines. And so that is our solution to this system of equations. All right, moving on, example 2. So here we have a unique equation. So y equals 2. And then we have our normal equation down here on the bottom. So anytime we see an equation where there is no x value, we should know that that's going to be a horizontal line. Okay, if we have an equation where there's no y value, that's going to be a vertical line. So since there is no x variable here, that means that this 2 is our y-intercept. And the only reason that they wouldn't put an x in this equation is if the slope was 0. So we have a slope of 0 and a y-intercept of 2. So literally, we just have a horizontal line that crosses at y equals 2. So that's our first line. All right. Then we have a y-intercept of 1 and a slope of 1/2. Okay, so we're going to start at 1 right here. Not that first point, I didn't mean to put that. So right here. And then we're going to run 2 and rise 1, and we can already see where our point is. We can go the other direction as well. And so there is our nice line. We want to make sure we graph those, make sure our lines are nice and straight. So our solution is right there where the two lines intersect, and that is at 2, +2. Okay, so I think you're getting the hang of it. Why don't you go ahead and pause the video and try number 3 and number 4 on your own. So to start out, my y-intercept is -1, my slope is 3. Okay, so -1, and then I'm going to run 1 and rise 3, because remember that's 3 over 1. I can go the other direction as well, drop 3 and to the left 1. And for these system graphs, when you're doing these by hand, guys, it's a good idea to put as many points as you can on the line or on the graph. All right, it just makes your life easier later on down the road. So second equation, y-intercept is -4, slope is also 3. Okay, so we've got a y-intercept of -4. which is here, and we're going to run 1, rise 3, run 1, rise 3, run 1, rise 3. And if I had drawn my first line nice and straight, it would be easier to see this, but basically these are two parallel lines. They're never going to intersect each other because this first line I didn't draw very clean. Actually, I put my slope in the wrong place. Huh, I just caught that. Let me redo this first line real quick. I wonder if you caught that whenever I was doing it. So we're at -1. Okay. All right, so now we can see it better. My line is nice and straight. So these are parallel lines, okay? Parallel lines are no solution, and that's because they never intersect. And we can actually pick this up right here. When we have different y-intercepts but the same slope, that means no solution. These two lines are not going to intersect because they're starting in different places and they're growing at the same rate. So this would be a no solution system. Okay, so moving on, example 4. Pause the video if you haven't done this one yet. So here I have a y-intercept of 4 and a slope of -1. So I'm at 4, and then I'm dropping 1, running 1, just like that. Okay. Remember, if our slope is negative, we're dropping, but we're always running to the right for the run, for the x value. We got a y-intercept of -1 and a slope of 1/4. All right, so we're starting here. So we're rising 1 and running 4. So right there. Let's go ahead and put one more point down though on the other side so we can get a nice line. So one solution. We have a point where the two lines intersect. That point is at 1, 2, 3, 4, 0. All right. Now, if we're asked to solve a system by graphing and we're given two standard form equations, the first thing we have to do is convert these to slope-intercept form. So that's what I'm going to do. I'm just going to basically solve for y. All right, that's what I'm doing. I'm going to solve for y. So I'm going to start by subtracting x on both sides, and I get y equals -x plus 5. And I put it in that order just because I want it to be mx plus b. Okay? So I'm going to do the same thing, or actually the next equation is fine. So the next equation is already in slope-intercept form, so I don't need to do any legwork. So now I can just graph these. So we'll use red for the first one. I have a y-intercept of 5 and a slope of -1. So I'm starting at 5, and I'm dropping 1, running 1. So just like that. Put as many points as you can, just because you never know where these two lines will actually intersect each other. Okay. Next, I've already got a slope-intercept form here, so I'm going to just start with my slope and my y-intercept. So I'm at -3, and I have a slope of 3, so 3/1, and it's going to intersect right there. Okay, so my solution right there, that's at 2, +3. All right. Okay, last one. So example 6. Go ahead and pause the video. Try this one on your own. Give it a shot. So first thing I need to do is solve for y. Okay, so I want to get y by itself right here. So I'm going to do that first by adding 4x to both sides. All right, so I get 2y equals 4x plus 2. Last thing I'm going to do, divide by 2. And I get y equals 4 divided by 2 is 2. And then 2 divided by 2 is 1. So I have a y-intercept of 1 and a slope of 2. So we'll go ahead and do that. We can go in both directions. Remember that by reversing both directions. Okay. My second equation is already good, so I got a y-intercept of 1 and a slope of 2. All right, now notice this. These two equations are now exactly the same. Because they are exactly the same, this is the exact same line. So it's going to be, I'm going to be putting the exact same line down on the graph. Okay? It's the exact same. All right? So because it's the exact same, this is an infinite solution system. So same equation equals infinite solutions. And what that means is that any point on the line is a solution to this system. So my solution is infinite. And that's it. Okay, so if you ever run into that where you run into the exact same equation, just know that your answer is infinite solutions. All right, that's it. So short and sweet video. Let me know if you need help with something. All right, good morning, guys. Welcome to lesson 4.1. In this lesson, we're going to be looking at how to graph a system of equations or systems of equations. So we're going to be building upon what we learned about in Unit 2, which is all our linear equations, so slope-intercept form, standard form, and so on. And we're gonna basically learn how to deal with a situation that is represented by two different equations, which we call systems. So steps to graphing a system. So let's just make our graph word nice and pretty here. So steps to graph systems. Step 1, we're going to make sure that both equations are in slope-intercept form, which is y equals mx plus b, okay? If not, we're going to rewrite the equation to solve for y. So for example, if we have an equation that's in standard form, the first thing we're going to do is solve that equation for y before we start to graph it. Then step 2, for each equation, identify the rise. No, hold on a second. Sorry, not rise. Identify the slope, which is the m variable, and the y-intercept, which is represented by b in our formula. Okay, so we first need to know where our slope and y-intercept is of each equation. Then we're going to graph each equation by first plotting the y-intercepts. So we start with the y-intercept where the line crosses the y-axis. Then from the y-intercept, we're going to apply the slope. Okay, remember slope is always rise over run to find the remaining points. Okay, and then the last thing we need to do is connect all the points on the line. All right, so we do that by just drawing a line through the points with arrows on each end. Okay, so once we've graphed both equations, so we're talking about a system made up of two different equations. We're going to graph each one on the same coordinate plane. Once we do that, we're going to locate the point that the two equations intersect. Okay, so there's a specific point where these two equations will intersect on a line. And that point of intersection is called our solution. All right, and that solution is always going to be an XY pair. Okay, we'll always draw a box around our solution when we say like, okay, the solution, the point of intersection where these two lines intersect each other is at whatever it is, -3, 5. So what we're talking about here is, let's say we have, okay, so let's say we have a line, you know, something like, oh, hold on. I don't know what I'm doing here. Hold on. Okay, that's not a shape tool that's going to work. So let's say we have a line, something like, I don't know, crosses the y-axis is at -3, And let me make this a little bigger. And then something, maybe it rises 3 and runs 2, so we have a line, something like that. So there's our first line, okay? And then let's say we have a second line that, looks something like this. So this is what we're talking about. So a one solution system is gonna be 2 lines that intersect at a specific point, okay? And that point of intersection is what we call our solution, okay? So this point right here, this is the solution. And in terms of a system that has one solution, we have one point of intersection where these 2 lines touch each other, they cross over. That point is on both lines, so therefore it is a solution to the system. We can also have equations that have no solution, and that would be an equation where basically the 2 lines are never going to intersect, meaning they are parallel. Parallel lines will never intersect. And so if we have 2 lines that will never intersect each other, that is a no solution system. So if you wound up graphing both of your lines and that's what you saw, it's a no solution system. And then finally, infinite solutions is where we're going to see basically the exact same line. Okay, so if we had, let me get something really small here. So if we ended up graphing both of our lines and it wound up being the exact same line, then we have infinite solutions, meaning every single point on the line is a solution to the system. So that's what the 3 different types of solutions looks like on a system graph, okay?